name is Mark Ellis from Stick and Rudder Studios, and today I want to bring you through a tutorial on X-KeyPad and how to configure it to work with an X-Keys device. Today we're going to be working with the XK80 and the Baron 58 as an example. And if you watched the installation tutorial, we showed you how to move the sample files to the respective places in the aircraft directories. So what I'm going to do now is open up the configuration file for the Baron 58 and kind of walk you through what the file looks like, what the columns are, and then we'll get into a much more detailed discussion. So I'm in the X-Plane 11 aircraft directory, Laminar Research Baron 58, and as you can see, I've already copied over the configuration files. This is the one here, the CSV is really what X-KeyPad reads. But as I indicated in the installation tutorial, I like to try to hang on to my definitions in a native Microsoft Excel format. And the reason for this is that if I resize my columns, or maybe I want to do a little color coding or things of that nature, I can do that in the Excel format where the CSV is just a simple text file. It can't keep track of all of that nice formatting. So I always work with the master in a spreadsheet, and then when I'm ready to run it or operate it, I just do a save as a CSV so that X-KeyPad can read it. So let's open this up and take a look at what's inside. Okay, so what we have here is in the very first column, and let me just move this over here so we can walk through it, is we've got the key name. And you can put whatever you want in here. It's really irrelevant, but I try to keep it so that the name column kind of matches the legend I'm going to have underneath the key. It helps me just a little bit to keep track of what's going on here. The next column is a comment column. You can put a string of comments in here if you wish about what's going on with this particular key. One thing you have to be careful of with comma delimited files is don't put any embedded commas within any of these particular fields, because it can kind of mess up the formatting of the file. The next column is the X-Key unit number. Some of you may actually decide to purchase more than one X-Keys device, and you can have multiples of them connected onto your system, and they're going to be numbered 0, 1, 2, 3, a little bit kind of depending upon which USB port you plug your device into. So if you're going to specify different keys for different units, this is where you'd put the unit number in you're talking about. If you only have one unit, then it would be unit 0, and by default, if you don't put anything in here, that's what's assumed, is that it's unit 0. If you recall in the documentation, we do have the ability with X-Keys devices to have a shift mode on it. And let's say as an example, an 80 key device like an XK80, you can actually have up to 160 key definitions. And which one's going to operate is simply going to depend on whether or not the unit is in shifted mode or not in shifted mode. And you indicate that definition by saying, you either put a 0 or 1, 0 or nothing. Nothing would be the equivalent of a 0, or you put a 1 in there, and the one indicating that it's in shift mode, and then you have whatever definition you've got for the key for that particular shift mode. Then you've got the key number. And before we go any further, let's actually take a look at what the layout of these, how the keys are numbered on the X-Keys devices. So let me just bring this image over here so you can see it. So this is an image of an XK80 and frankly an XK60. They're, for all intent purposes, they're the same unit. It's just that the 60's got a few less keys, and it's got some key blockers, I think, in these rows right here. But the keys are numbered 0 through 7 in the first column, and then 8 through 15, 16 through 23, all the way up through 72 through 79. So this key number here matches that number there. Okay. The next thing we have is a logic data ref, and this is optional. It depends upon how you're trying to drive your backlighting and your commands, okay, on the key. In some cases, we'll take a look at something simple down here where I've got a COM transfer button. These are just the arrows on the, let me actually bring that image up so you can see it real quickly here. Here's my XK80 layout that I've done. These are the COM transfer arrows, and all they really do is they move you from standby to active on the COM channel. So there's no logic behind these things. I just have the blue LED always lit in these. It doesn't really, you know, I don't have it doing anything like trying to light the red LED or have it flash or anything like that. So in a situation like that, you don't really need to have a data ref behind it trying to drive anything. And in a minute, we're going to have a discussion about what data refs are and what commands are in a minute. But for a moment, just assume a data ref is data that we're going to use to make a decision, either what LEDs we want to have lit, whether we want them flashing or not, and which commands we might want to run or not run when the key is pressed based upon what the state of that data ref is. We'll discuss this float scale factor in a little bit. There's an example of where we'll actually use it. These next few columns here, the bank 1 on, bank 1 blink, bank 2 on, bank 2 blink, all have to do with the LEDs. Now these X-key devices, they've got two banks of LEDs. There's basically two colored LEDs under each key. There is a blue LED, which they consider bank 1, and then there's a red LED, which is considered a bank 2. And the LEDs can have three states. They either can be off, they could be on solid, or they can be flashing. Okay, and in this column here, these columns, you can put a logical expression, which we're going to discuss in just a couple of minutes, to evaluate, let's say an example, a data ref. And based upon that expression, if the expression ends up evaluating as true, then that particular LED state is going to be on. It'll either be, you know, if it's false, it'll be off. In this case, if this one evaluates to true, we'll put the blue LED on. And if this one's false, it'll then come over and take a look to see whether it should be flashing or not. So we'll get into a greater discussion on how these actually work. Similarly over here in the command logic test column, similar to the LEDs, I can look at the state of a data ref, that data ref to the left there, and with a logical expression, I can decide whether I want to run one set of commands or a different set of commands. And this is pretty useful when, you know, as an example, maybe you don't have a toggle command for a particular function. It's either like fuel pumps on or fuel pumps off. And if you want to have one key be able to toggle back and forth, you kind of need to know what state are the fuel pumps in now, so I know what command to run. Okay. The next thing you have is your true and false speech. And this is again optional. You can have the simulator repeat back some text when you press the key. In this example on the flight director turning it on or off, I could say, if I'm turning it on, I can have the simulator say flight director on, or I can have it say flight director off. And I actually think I can probably show you doing that here just a minute.
Flight director on. Flight director off. So
I just press the flight director button on the on my XK80, and you could see how that works. And again, these are completely optional. You can put text in here if you want that. The other thing you do is you can put text in here and then globally shut it on and off with the settings on X-KeyPad. The next thing is a numeric data ref. Now, in some cases, we may want to either A, give you the ability to enter a numeric piece of data on the little keypad, and then set that into a data ref. A good example is the COM frequencies. I can have it so that when you press this COM1 button, if you've entered some numbers into the keypad, then when you press that COM1 button on your XK80, what it's going to do is take that number and it's going to jam it into this data ref, thereby setting the COM frequencies. And the reason why this numeric data ref is different than the logic data ref, in some cases they could be the same, but in some cases you've got one data ref that's driving, you know, what you want to show on the LED, and in the other case you might have a different data ref that you're trying to set if I enter in some information into it. This numeric data ref can also be used for incrementing functions. In some cases, you can actually control what's going on with the simulator either through the use of a command which we're going to discuss in a minute, or sometimes you have a writable data ref behind it, and I can jam values into that data ref and get the simulator to do different things. A good example of this that we're going to use is going to be the Transponder Mode, where it's actually a multi-position rotary switch, and I'd like to try to, do some magic, okay, to use one key on the X-key device to actually control that transponder mode by being able to increment it up or increment it down. So that's another thing that you can do with a numeric data ref. We'll talk about this multiply by when we get to the comm frequency discussions. Data refs can have a min and max value, so that you're not allowed to set it to something that's invalid. It's also used in these min-max values in the case where you want to be using it to control the simulator by incrementing the thing up or down. And this column indicates if you do have an increment function, how do you want it to operate, up, down, or example wrap. And again, we'll get into this in greater detail in a few minutes. And then, as with the command speech, you can have numeric speech. Let's take a look at the comm frequencies. An example, I say here that if I'm going to set the COM1 to a particular frequency, I can have the simulator repeat back COM1 set to, and bracket n bracket indicates whatever I had entered on the keypad, megahertz. And again, this speech is optional. If you don't want it, don't put it in here. You can leave it blank, or you can put it in and then globally shut it off, turn it on and off if you're feeling like it at the, in the settings for X-KeyPad. So that's kind of a general layout of what the file looks like. Okay, let's now take a look at, have a brief discussion about the difference between commands and data refs. Because sometimes if you're not familiar with this, it can get pretty confusing. When you look in the definitions, you're going to see that the way we refer to these things, the naming of them is almost identical. So it can get a little bit confusing. So basically, what a data ref is, it's information that's in the simulator. And these are typically numeric values. They can be integers or floating point numbers or arrays of integers or floating point numbers. Commands are actions. So let's take an example, which you're probably most familiar with is mapping your yoke, the buttons on your yoke, to doing specific things in the simulator. When you go into the X-Plane 11 interface and you associate those buttons, okay, with those commands, those are commands that you're actually associating it with. Usually within the X-Plane 11 interface, I don't think there's any place where you actually work with data refs. It's something unique that's done either with Lua scripts or in a tool like X-KeyPad, where you actually want to look at the data in the simulator and then do something, based upon what state it's in. So those are the two different things. And what I'm going to do now is I want to actually show you how these things work in the simulator. So we've got X-Plane 11 up, we've got our Baron 58 loaded here. And in the documentation, you'll notice that I talked about this thing called the dataref tool. It's a great little plugin. There's a URL in the documentation that tells you where you can go get it, that actually allows you to get in and look at data refs, manipulate commands, even do things like search for data refs and commands. So it's really a fantastic tool. And I'm actually going to bring it up here and show you an example of commands and data refs. So here's the data ref tool. First thing I'm going to do is bring up a viewer for commands. And then I'm going to bring up a viewer for data refs. So I can have kind of two of them up. So these are operations, things I can get the simulator to do. And this is a data ref, okay, behind it. And what we're going to do is I'm going to show you an example of the audio panel. This is basically this part down here of the simulator where, and I actually think I can do this if I just push the COM2 button, right? So do I want to listen to COM2 or do I not want to listen to COM2? Okay, and let me just show you the image over here that I've got. That's these buttons right here. COM1, COM2, NAV1, NAV2. Okay? Okay, so what we're going to do is we're going to want to find the command associated with that button and the data ref behind it, because in a minute I'm going to actually show you how we can use that data ref to control the state of the LED behind that particular command to data ref. So the data ref that indicates the state of this, we can actually do a search for it. If we search for audio, it is right here. Audio actuators, COM1, COM2. So what I'm going to do is I'm going to press the COM2 button, and you can see where that data ref changed from a 0 to a 1. See how it's doing that? This is changing down here, and the data ref is changing over here. Now if I come over here and I press, and I'm pretty sure the command is called audio. Yeah, here it is. And I think if I press this, I think this will flash. Yep. I'm pressing the button, the COM2 button on the XK80, but I can also do it in here. Notice how it's changing. So this data ref tool is just absolutely invaluable for being able to hunt down commands. What's the data ref behind it? That type of thing. And frankly, if you're trying to make your panel, your X-Keys work with a custom plane, often these custom planes will have a bunch of custom data refs and custom commands that they've added. Most of the time they document them, but sometimes you got to hunt around and try to figure out what they are. And you'll see this if you look at a lot of the sample files, particularly the ones I did for the Aerobasque Diamond, and even the default 737 is a plane that Laminar didn't write themselves. They actually had somebody do it for them, so it's even got some custom data refs in it that are uniquely defined. Okay, another thing about where you can find information about commands and data refs is right over here. Let me just so in X-Plane 11 resources plugins, there is a datarefs.txt file. And this lists all of the default data refs, okay, that the simulator is aware of. And again, it's not the complete list, because if you load up a custom plane or a third-party plane, it may very well be that it defines a bunch of its own data refs. Even plugins can come along and define their own data refs. There's a corresponding file over here in X-Plane 11 resources plugins called commands.txt. And this is where all the commands are. So what's nice about these files is they actually give you a bit of a description about what is going on here. Okay, whereas if you just go in the data ref tool and hunt them down, you're not going to get any explanation as to what they mean. Here in the data refs, it'll actually tell you, here's the reference for the data ref. It'll tell you whether it's a float, or an integer. Tells you whether it's writable or not. That's what this little y or n, means. And you get a little bit of a description about what it all means and what it does. So these are pretty useful text files that you're going to want to look at on occasion to see what they mean. Okay, data ref types. So you heard me talk about this a little bit. Data refs come in a couple of different flavors. One, or the most common one, is simply a 32-bit integer. And in some cases you can have arrays of 32-bit integers. In other words, the data ref actually represents not just one integer, but a group of integers that can be referenced with an array index. The next type you can have is floats. And these are floating point numbers like, as example, your engine RPM is going to be represented probably as a float. Things like flaps deployment ratio, would be a float. This is a number that goes from 0 to 1, so you've got decimal points in it, like 0.1, 0.2, 0.3 for your flap deployment ratio. And similar to integers, you can have arrays of floats. The next one's a double. And as far as you're concerned, a float and a double are the same. They're the same thing. They're numbers with fractional parts to them. The difference with a double is it can represent very large numbers or numbers with really a high degree of precision to them, lots of decimal points, lots of numbers to the right of the decimal point. You probably don't have to worry about that too much. And the last type of data ref is effectively what they call data, and it's a byte. It's a single character of data. Typically, you would manipulate those with arrays. Now, so for our purposes with an X-KeyPad, we're mostly going to be working with these two types here, either floats or integers. And something to keep in mind with X-KeyPad, all of its logical expressions tend to always want to work with an integer. And we've actually got a technique, okay, where if you've got a floating point number that, let's say as example, it ranges from 0 to 1, so it's only got like, 0.01, 0.1, 0.2, up to a maximum 1. We've got a technique, okay, with a multiplying factor that allows you to scale that up, okay, so that it could be an integer rather than going from, let's say, 0 to 1. We can multiply it by 100, and thereby turning it into an integer that goes from 0 to 100. And the reason why we do this in X-KeyPad is X-KeyPad does have the ability to do a bitwise AND operation, which we're going to talk about in a little bit. But you can't really do that with a floating point number. It's always got to be converted to an integer. But I thought it was important for you to understand, under the covers in the simulator, we do have these different data types. And as I think we already showed you here, there are these text files that you can look at, commands.txt, datarefs.txt in the plugins directory. And do keep in mind, okay, that this is not going to be an exhaustive list of commands and data refs. Custom planes, third-party planes, they all typically define their own set of commands or an extra set of commands above and beyond what they respond to for the simulator commands. Same true with data refs, and plugins often have their own set of commands and data refs that they may be defining to do different things. So just keep that in mind. And the data ref tool is the best way to experiment with commands. We kind of showed you a little bit in the simulator, how you manipulate that, and we're going to be working with that quite a bit as we go through the tutorial. Okay. So the next thing to talk about is comparisons and logical syntax. So let's just bring up this spreadsheet again real quick. Bring that over here so we can take a look at it. If you look at these columns here for the lead blanks and the command logic, this is the logical expression that you want to put in, that you're trying to decide whether or not you want that lead lit, not lit, or whatever. And in here we can put a mathematical expression to compare a literal number, which are the numbers that are in here, with the value that's currently in this logic data ref. So this is the comparison logic syntax that we'll be using when we go through those and try to put stuff in those columns that I just showed you. And it's pretty straightforward. Equal to n means I'm comparing the data ref to the value n. If they are equal, then that will evaluate to true. Greater than n, if the data ref is greater than the literal that I put in, it'll evaluate to true. Less than n is pretty obvious. Ampersand n is a bitwise ANDing operation, which we'll look at in just a minute. Sometimes in the simulator, simulator states are represented using just one number, and then they'll set bits on and off within that. And we'll take a look at that in a minute when we look at a more advanced example where we need an ANDing operation. Okay? Not equal, so I can invert the logic with putting an exclamation in front of it. So in this case, I'm comparing the data ref value to n, and if they are not equal, then it will evaluate to true. Same is true with not greater than, not less than, not and, okay? And there's sort of a shortcut here. If I just put in a number or a not number, that's the same as doing a bitwise AND operation, okay? Okay, ANDing. And again, we'll probably review this again in just a minute when we get to the detailed example of where we use this. But the way ANDing works is, if you have a decimal value, let's say as an example here, a data ref value of 11. The binary representation of that is 1011. Okay, this is bit 0, bit 1, bit 2, bit 3. And in the documentation, there's actually a URL to a decimal to binary and binary to decimal converter utility on the web. That it's really great to go use that, okay, and take a look at it. The mask, which is that literal value that you put in there, if I were to say I'm going to AND the data ref value with the value of 2, this is what the mask looks like in binary, 0, 0, 1, 0. Okay, and the result is simply doing a logical ANDing. As an example, if I see a 1 and a 1 in both pit positions, that will end up as a 1 down here. If I only have a 1 in one but not in another, that's 0. Or if I have, you know, a 0 and a 0, that's 0. So in order to get a 1 in the result, it has to have both bits in that position have to be on, okay, to make that. And since this 0, 0, 1, 0 is going to end up being some value other than 0, that ends up being true. So the concept of true, it's simply any non-zero value. That could be, you know, -1 all the way up to, you know, 64 million or whatever the upper level max is, okay, for a 32-bit integer. 0 is the only thing that indicates false. All of the numbers are considered to be true. Okay, so with that in mind, I think what we can do is go back and take a look at some simple examples of how we can control these LED backlighting and what commands we're going to get executing. So let's come back over to our configuration file, and let's take a look at something like a simple static LED assignment, okay? And I'll come back to these transfer arrows on the X keys. In this case, I don't have any logic behind the darn things. All I'm trying to do is just I'll light the blue LED underneath that key. So what I've done here is simply put in a non-zero value in the bank 1 on column. Now, by default, this is effectively equating to a logical AND. And the way this works is, if there's no data ref, then what X-KeyPad is going to assume is the data ref number, or the value I would have gotten from a data ref, is just going to default it to a -1, which is all bits set. That's what if you go to actually do that decimal to binary conversion for a 32-bit integer, if you put in -1, you're going to see that every bit is set in the binary number. So you could pretty much put any number you want in here, 1, 2, 3, 4, 5. As an ANDing operation, because of the fact you have no data ref behind it, it'll always AND it with a -1, and that's going to pretty much end up with any number is going to end up with any non-zero number is going to end up with it evaluating to true. So in this case, the blue light would be lit. If I wanted, let's say for instance, I always wanted those transfer things to flash, I could simply come in here and set this to a 0, set the blink to 1, so now the blue LED would be blinking. Maybe I want it to be red. If I put this on, then the bank 2, which is on, which is the red LED, now that's going to be on. Or if I wanted to red to flash, I could do something as simple as that. Okay? So that's what you would get for a simple static assignment. If I didn't want if I didn't want the LED on at all, you just put it to 0 like this. Okay? Or leave it blank would be the other possible thing that you can do. So that's an example of a simple static LED assignment. Okay, if you have a data ref behind it, then chances are what you're really trying to do is get the light to light up or not light up. So let's take a look at what's probably a good example of that. I think, you know what, these COM ones are a pretty good example. So if you remember correctly, we were actually looking at this with the data ref tool. These are the COM monitors. So this is the data ref, and it's send cockpit radios, actuators, audio selector, COM2. And this is a simple integer data ref. It's either 0 if I'm not monitoring COM2, or it's a 1 if I'm monitoring COM2. So look at the simple equation I put in here. If this data ref value is less than 1, I could have also put equals 0 in here. It will do the same thing. What I want is the blue LED on. And if the value is greater than 0, in case where it's 1, where it's actually on, I want the red LED on, steady. Okay, so that's kind of an example of how you can control the LED backlighting based upon a logical expression and what's going on with that data ref. Okay. All right, let's take a look at this concept of being able to set a numeric value. Now I do want to come down here and show you something down here. Here are the numeric keys on the X-Keys device. And let me just bring this over here for you real quickly to remind you what that looks like. Okay, these are these keys here. 789, 4567, 101, clear. Okay. There are special commands in X-KeyPad that when it sees that command executed, it will enter that corresponding number into a numeric buffer. And if you remember from the demo video, if you have numbers in the numeric buffer and then you press a particular key, rather than operating the command behind that key, it'll actually set data in a data ref. Okay, and I'm going to show you that in a minute when we do it for setting the altimeter, in the plane. So these are the key definitions for those keypad keys, and when you press them, these are the commands you need to execute. SRS, which stands for Stick and Rudder Studios, X-KeyPad, keypad underbar 7. And what that does is it puts a number in the number buffer. I actually think I can probably show this to you in the simulator. I'll actually bring up the little handy dandy data ref tool. And here they are. Now, if this is working properly, if I press this button, sure enough, numbers are starting to show up. I'll press this one. See? So all I've really done is mapped those keys on the keypad portion of your XK80 to simply execute these commands. And here's the clear command. That clears it out. Okay, minus. You see how it works? Okay, it also gives you kind of example of the data ref tool and the kind of cool things you can do with it to kind of poke around and see what commands do what and what data refs do various things. Okay, so I'll just come in here and clear this out again. Actually, I'm going to press it on the keypad here. I just did it, press the clear button on the XK80 and you can see that it cleared it out. Okay, so that's what this is all about, these key definitions. You'll notice something real quick here when it comes to the shift. You notice that I put the definition in twice. Once for shifted, and again, once for non-shifted and again for shifted. And the reason for that is that I always want that keypad to be active, even if the X-Key device is in the shift mode. So if you look at these two lines, you'll see they're identical. That's the only thing I changed, right? So 7, it's key number 44. I got two lines in here, but the lines are identical other than, that shift flag, being different, okay? All right, so that being said, let's take a look at an example of where I want to have a key do two different things, okay? So let's take a look at COM1. So to start with, I've got the logical data ref to determine whether I want that little LED behind it lit or not lit based upon whether COM1, let's use COM2 as an example, whether COM1 or COM2 is, is being listened to. Okay. Here's the command that you execute, and that command there, I showed you us using that with the data ref tool. That simply toggles the COM2 audio monitor on and off. Okay. So if I have no numbers in the number buffer, okay, and I press that key, then what it's going to do is it's going to toggle COM2 on and off, okay? And I can actually show that to you really quick. If we bring the simulator back over here, and I'm going to press the COM2 button on my X-K80, see what it's doing? Notice no numbers in the number buffer, okay? But if I were to put some numbers in the number buffer, and I'll put in 124.5, and now I'm going to press COM2 or COM1.
COM1 set to 124.5 megahertz.
See how it set it? Okay. I'll do that again. I'll put in 123.6.
COM1 set to 123.6 megahertz.
Okay. Now let's take a look at how that magic happened. Back over here. So that's the command that gets executed to toggle the monitoring on and off. Okay. If we come over a little bit further, you'll see that I have a numeric data ref associated with this. And this is the way X-KeyPad works. If in the key definition, it sees that you've got a numeric data ref definition for that key, okay, then what it does is, when you press the key, it does two things. First, it says, if there's no number characters in the number buffer, I'm just going to come over and execute the command. Where is that? Right there. However, if there are numbers in the number buffer, then what I'm going to try to do is set this data ref to that value that I entered. Now we have a rather unique situation here with these data refs. If you look at the documentation in datarefs.txt, you're going to find out that the values that this wants, it wants it in 10 kilohertz increments. However, that's not the way we want to enter it. It's much more convenient for us to enter it in megahertz, like 123.5 megahertz. So we got to convert it before we set it. So that's what this multiply by does. It says, if I got a value in this multiply field, it'll take whatever you entered on the numeric keypad, it'll multiply it by this value, and then it's going to jam it, into that data ref. So that's how we're able to enter those numbers and get that single key for COM1, COM2, or whatever to either do one of two things. Either A, it'll toggle the audio panel on or off, or if there's a number in it, it'll actually set the COM radio frequency. And then we also have this optional numeric speech, okay, that we can say that after I've set it, if I've put something in here, the X-KeyPad will try to do basically a text-to-speech conversion and actually say those words, like COM2, set to, and then there's some syntax in here where you can say like bracket n bracket, and have it repeat the number that you entered, megahertz. Okay, so that gives an example of how you can set a numeric data ref or have a key do two things, and you're going to see a lot of these like this. Okay, heading mode is another good example. So this is the heading key for the autopilot to turn heading hold on or off, right? So that's the data ref that we can look at to determine whether I want to show, the LED on or off, depending on whether heading hold is on. That's the command to toggle heading mode on or off on the autopilot, right? But I also have this data ref behind it, and I've said that I don't need to multiply because I'm going to enter it in degrees 0 through 360. I have a min and a max value here, so if I try to put in something ridiculous like 370, I'll actually get an error message, okay, saying that you try to set it to something that's invalid. And then we've got this text behind it, okay, to say setting it to, a different value. So I think I can actually do that here. I'm just going to put in 250.
Heading set to 250 degrees.
Okay. So you kind of see how that works. Okay, and you'll see, like I said, that concept of a numeric data ref doubling up on a key, with a command behind it is a pretty common thing. Okay. Oh, here's another example of this. Okay, where actually we don't even have a command behind it that I want to show you is the altimeter. Yeah, I've got it right here. This is for setting the altimeter setting. For setting the barometric pressure for the altimeter setting. So this key, the baro key, let me bring up the picture here real quick. It's this one right here. It's always blue. There's no logic behind it, so we don't have it doing anything. There's actually, frankly, even no command behind the darn thing either, because there's nothing specifically you can do with the barometer on the altimeter. So if we come back over here and we look at that definition, where did it go? Here it is. You'll notice that there's no logical data ref behind it. I just simply have the blue backlight on it, so at least it's lit up. No commands, no nothing, but I do have this numeric data ref behind it. Okay, and whatever I enter will get jammed into there. So example, if I bring the simulator over. Currently it's at 2998. Let me change it to 30.05.
Altimeter set to 30.05 inches of mercury.
Okay, so you kind of see how that works. That's an example of one where, all I'm using the key for is to set the altimeter. It doesn't do anything else. Okay, what else do we have on our agenda here? So we went through the radio frequencies. Okay, let's take a look at using a logical expression for selecting different commands. And I think the gear might be a pretty good example of that. Okay, so let's talk a little bit about the gear. So there is a data ref in here. And it's actually an array. This is probably a good way to show how arrays work. And the way you reference an array is at the very end of the data ref, you would put a bracket around it, and you would put the index you want to look at. So in this case here, I'm actually looking at I think it's the index 1 is the right hand. It's actually the main gear. Okay, is what I'm looking at. I think index 0 is the nose gear. And then 1 is the starboard main gear, and I think 2 is the port side, main gear. In this data ref is a number that goes from 0 to 1, indicating the percent or basically the amount of gear deployment. Okay, so as an example, if the data ref is a 1, it means the gear is fully deployed. If it is a 0, it means it's fully retracted. And it can have numbers in between like 0.1, 0.2, 0.3 to indicate the percent that the gear is deployed. So if you remember in a little while ago, I told you that X-KeyPad's logical expressions, they only work with integers. They can't work with fractional parts. And again, the reason for this is because the ANDing operations have to work with integers. So the first thing I'm going to want to do is scale this up. So when I come in and I try to do any of these logical expressions, the first thing X-KeyPad will do is it'll read the data out of the data ref, it'll multiply it by 100, and then it tries to do the comparison. So let's just take a look at the LEDs, and then we'll look at how the command works. So if it equals 100, I'm basically going to have the blue LED on steady, indicating that the landing gear is fully deployed and down. Okay, if it is less than 1, indicating that it's fully retracted, then I'm going to have is the red LED on. Okay, and if that doesn't evaluate. In other words, if this evaluates to false, then it's going to come over and take a look at the blink state. And here I'm saying is if it's less than 99, in other words, it's not fully deployed, then clearly what it must be, and it must be in transit. So what's going to happen is the gear LED will flash, you know, as the gear is somewhere in between, you know, 0 and 100. Okay. And then I have a command logic test here. So I'm saying is if the gear is greater than 99, then the gear must be fully deployed. So in the case when I press that key, oh, actually I need to come up here and look at this gear because I have my gear button spans 2 keys and I'm only using the left hand one. Okay, the left hand button is the one where the logic is. Okay. But I want to, you know, light both LEDs underneath. So I need to come up and look at the button under the double gear key. I need to look at the one on the left, which is the one where the logic is actually being driven from. So in the case where the gear is all fully deployed, in other words, this value is to true, it's greater than 99, it's fully deployed, then what I'm going to want to do is toggle the landing gear. And you'll notice that the false command and the true command are basically the same because it's nothing more than a toggle command. Now, if I actually had a separate command for gear up or gear down, I could have these be different. But the reason why I'm using a logic test here is I want to have 2 different texts come out. Okay. In the case where the landing gear is fully deployed and I press the key, I want it to say retracting landing gear. And in the case where the landing gear is actually fully retracted and I press the key, I want to say I'm deploying the landing gear, right? So it kind of gives you an idea how that works. And again, if in the simulator I didn't have a common toggle command, I actually had, like I said, a gear up or a gear down, which I actually think there might be like that. I could have had 2 different commands in here and executed whichever one I needed to based upon the state of that logical expression. Okay, so in many cases you can control things with commands, but in some cases it gets a little clunky. And what I want to do is show you the example of the transponder mode. So let me bring the simulator back over here. Let's get the view looking at the transponder, and I'm going to bring the dataref tool up. So I've got my commands, and I got my datarefs. And let's just search for trans, okay? And there's quite a few commands for the transponder mode. You can like set individual digits, you know, take individual digits and move them up and down, all kinds of things. But what I want to take a look at is this command right here, transponder up, which is going to effectively affect this little rotary switch here. Notice how it went up, up. But then when it gets to its max, it doesn't go anymore, okay? Now there's a corresponding one here called transponder down. That rotates it down. Okay, so now you have a choice of how you want to operate this. And I'm going to kind of give an example of the various ways you can do it and the way I chose to do it. So you could have had one button that says transponder mode up, and on that same key you could have had a shift function that says transponder mode down. Okay, so what would happen is if you want to move that little rotary switch up, you continually press the button. If you want to move it down, you have to hit the shift key on your X-K80 and then press it again and it'll come down. That to me felt a little clunky. Okay, you also could have done it something simple where you don't even try to move it through its various stages like standby and all these other things. It could have just simply be, when I press it, I want to jam it to on. If I press it again, I want to jam it to off. Okay. What I wanted to do is have a single key act kind of like an up-down rotary, that as I press the key, it would rotate that switch all the way to its maximum value. And once it got to its maximum value, if I kept pressing it, it would rotate it back down to the other value. Okay, and I just found a convenient way to do it. So I want to show you how you could do that with a data ref. So let me see here if I can find the transponder data ref here. Yeah, here it is, transponder mode. Let me just double check that. That's what it is. If I increment this, yep. So notice as I move it up, see how the transponder mode's going? And I can actually come in here and force it to a value. Notice how it changed, the little rotary switch. Okay, so what I'm going to do is configure X-KeyPad so that it manipulates this data ref. And I do want to caution you, not all data refs are writable. You do have the designer of the plane or however they're doing it, they could have data refs where they're just read-only. You can read the data, but you can't change it. And if you have a situation like that where you can't write to it, or in some cases they may make it so that you can write to it, but the aircraft model won't even respond to you writing to it. So you have to play with this a little bit because it can vary by plane to plane what you can and cannot do with data refs. But as this example, I was able to play with it and see I could write to that data ref and I could control what's going on with this rotary switch. Okay, so with that in mind, let's go over and take a look at the configuration for the transponder. Here we go, transponder mode. Okay, so that was that data ref. I use it, okay, to kind of make up my mind how I want the LEDs to flash. If it's equal to 0, making the transponders off, I want the blue LED on. If it's equal to 1, which I believe is standby mode, then I want the blue LED blinking. If it's equal to 3, which I think is fully on or kind of in mode A, I want the red LED on steady. And if it's not that, it'll look over here. If it's in mode 2, which I think maybe mode 2 is actually a standby mode. I can't remember exactly, which is which. We look at the command text. We can take a look at it. But in this case, I wanted the red LED blinking. Okay. I have no command behind it because what I'm going to do is use the increment mode on a numeric data ref to manipulate it. And if we come over here and we take a look at it, that's the data ref I want to manipulate. I don't need to multiply it because it's a simple integer. It's going to go between 0 to 3. Those are the states that we've got on it. And I can specify the increment mode. In other words, the mode could either be up, down, up, or wrap. Okay, so up, down means that when I press a key, if let's say the very first time I press that key, if the mode is the minimum or below the maximum, it's going to increment it up. If it's all the way up at the maximum, it'll start incrementing back down again. If I did down up, as an example, the very first time you press the key, it's going to say if I am higher than the min of 0, I'll increment it down. And when it gets down to the min, I'll start incrementing it back up again. Okay, and it will only go between these values to min to max. Okay, and here's the text, okay, that it's gonna, say. So 0 is off, 1 standby mode, 2 is mode A, and 3 is mode C. And I have to double check this. I actually might have a mistake in this for the Baron 58. A lot of times when I did these samples, I kind of copied and pasted, and I might not have this text exactly right for the Baron 58. I should go back and take a look at it, or you can actually look at it yourself. But if it's wrong, just change it, okay, to what it actually should be. So that gives you an example of how you can use an increment up down, okay, to kind of do things. And you'll see there's a number of places where I've done things like that in the in the samples, because I could get more functionality out of a single key without having to be fussing with the shift button and that type of thing. But you can choose how you want to do it. Okay. So let's take a look at something a little more complicated with the bitwise AND operation. And this is primarily used on the autopilot modes. And let me actually bring something up here to show you, if you give me 1 minute. Okay, so this I actually have this link. I think is in the documentation, but this is a discussion of the autopilot state data ref, and it's right up here: sim cockpits, autopilot state, and this is a 32-bit integer, but each bit position is set means different things on the autopilot. An example, if decimal bit 1 is set, it means auto throttle is engaged. If bit 2 is set, it means heading hold is engaged. If bit 16 is set, it indicates that we're in flight level change mode or mode. If this bit is set, it means that the flight level change is engaged, right? So there's all of these different bit settings that mean different things based on what state the autopilot is in, okay? And the one I want to take an example look at is basically these two right here, HNAV armed and HNAV engaged. And for those of you that are familiar with the autopilot, when you're coming up on, let's say, a localizer, okay, but you haven't quite captured it fully yet, you can be in heading mode and you can put your HNAV into an armed mode. And what that'll mean is it'll stay on heading mode, heading hold mode, until such point that the nav radio detects that it's got a good signal on the localizer, and as soon as it does that, it'll flip it over to horizontal navigation engaged, and the plane will start tracking the localizer, okay, to adjust the plane's heading, okay. Same thing is true for doing the glide path, the type of a thing too. So in my case, I want to be able to control that nav key. I want to be able to have it flashing if I'm in armed mode. I want it solid red if it's in engaged mode, and I just want it to be solid blue if neither of these is set. So these are things that are important to remember. Remember the number 256 and 512, okay? And these are the two bit positions for it. 00100 if the ARM mode is on, 00200 if it's engaged. So let me find my nav. Here it is. Okay, so that's the data ref, autopilot state. And if you remember those two values, 256 and 512, this again, notice I don't have an operator in front of it. I could have put the ampersand 512 or ampersand 256, but by default it assumes, X-KeyPad assumes if you don't put an operator, it assumes you're doing an ANDing operation. So in this case what I'm saying is, if the bit that represents 512 is on, then I want bank 2 on all the time. And if that's not set, I then want to take a look and see if the bit representing value 256 is on. If it's on, I want to have the red light flashing, indicating that the horizontal nav mode is armed. Okay. Then what I do is I add these two numbers together. And if I add them together, I get the value of 768. You can see that down here in Excel. If you highlight two cells, it'll add them. And then what I'm saying is if either of those bits are not set, then I want the blue LED to be on. Okay, I realize it's a little complicated. To be honest with you, sometimes even I have been doing a lot of programming. Sometimes I've actually got to sit down with a piece of paper and draw the darn bit positions out and see what's going on. But that's how you can see how an ANDing operation is used. And in all honesty, the only places I've seen that you've got to do this is with the darn autopilot, because it's the one place I've seen in the simulator where they don't have individual data refs for all these different states. They did at one point in time, and then they did away with it, and they've simply got this one integer value that you have to look at each individual bit, and that's the example of the way that you can do it with X-KeyPad. Again, I think if you look at the examples and you sit down with a piece of paper and that URL I had, which is the write-up on what the autopilot states mean, you can get a sense of how this whole thing works. Okay. And it's simple true here too, that you can see where the speech I've got, where it's got different speech depending upon how it's evaluating. And you have the ability to gang speeches together separated by semicolons, and between the brackets you simply have the logical expression. So if it's not those 2 bits set, we say nav off. If it's the 512 bit is set, we're going to say nav on. And if the 256 bit is set, it's going to say nav arm. And just like the LEDs, it evaluates left to right. As soon as it finds a speech evaluation that works, that's the speech that's going to get spoken, and it completely ignores the rest of them. So you definitely want to formulate this in the right left to right kind of a fashion, so that the first one that hits evaluates properly and speaks properly. Okay. Now let's take a look at the last thing I want to discuss with you, which is how you can use Lua to do something more expansive. Okay? And I'm going to show you what I did with the cow flaps. So again, let's come on back over to the simulator. And take a look at these cow flaps. So the first thing I'm going to do is I'm going to come up here and I'm just simply going to stop the Lua engine for a minute, because I actually have a Lua script that I'm going to show you in a minute that's controlling these things, and I need to shut it off so I can show you how you would normally operate with the cow flaps. So bring up the dataref tool for commands, look for cowl, and here we have a whole bunch of commands here. Okay, you can control both cowl flaps together or each individual one. So let's take a look at the open command here. I think if I press this, you'll see that the cowl flaps are going down. Okay, and if I do this one, they'll go up. So to control the cowl flaps, I could have done this a couple of different ways. I could have, similar to the way I did the flaps button, I could have had a cowl flaps open, key, and then maybe with a shift I could have had a cowl flaps closed, or I could have used 2 keys, for a cowl flaps open, cowl flaps closed, and simply map them to these commands. But I wanted to do something a little bit different, partly because I didn't want to have to constantly be looking at the cowl flaps. I said, you know what? I simply want to have it so that a simple key press is going to increment the cowl flaps open in increments of 25%. Okay, and then once they get fully open, if I press it again, it's going to start closing them in increments of 25%. And I figured, for most cases, that's going to work pretty good for me for controlling my engine temperatures, okay, by closing down how much cooling air is hitting my engines on my Baron. Okay, now there's no way to do something like this purely using the X-KeyPad common delimited files. You need to have a lot more logic in it and in math to be able to do that. So in this example, I'm going to use a shared data ref, okay, and a Lua script to do some magic with this. And by the way, if you look at some of the other examples, particularly when you get into the more sophisticated planes like the Diamond 62 and some other things, there's a lot more use of Lua scripting to get it to do what you want it to do. But I'm going to show you a simple example with this. Okay, so let's leave this here for a minute. I'm actually going to come up and get Lua running again real quick. Get all the scripts running again. Now let's just move this out of the way, and let's look at our definition for the cowl flaps. Here we go. Okay, so the first thing you're going to notice is I'm using this shared integer data ref. And what X-KeyPad does as a plugin is it defines a collection array of shared integers or shared floating point data refs that you can use to interact with FlyWithLua. So in my example, I'm going to use a shared integer number 0 to indicate, to basically operate that as a multi-state a data ref. And it's probably easy if I come over here and take a look at how I've defined that, okay, as a numeric data ref. So here's the definition of it. And I said that it's got a minimum value of 0, a maximum value of 4, and I want it to work as an up-down type of a mode. So as each press of the call flaps key, it's going to go from 0 to 1 to 2 to 3 to 4. If I press it again, it'll go from 4 to 3 to 2 to 1 to 0, and just simply back and forth like that, right? And what that's going to end up representing is call flaps totally closed if it's 0, open 25%, open 50%, open 75%, or call flaps fully open. Okay? But in the end, I need to be able to manipulate a data ref in the simulator that's going to set that to that particular value. So let's go back over, bring the simulator back up here. So here we've got our commands. I'm now going to bring up the data ref tool. Search for cowl. And here you're going to notice that I've got a cowl flap deployment ratio. Okay, so let's actually see if we can do this. If I come up here to cowl flaps open, notice as I press this, oh, you know what? I've got to shut off the Lua script. Excuse me for a minute, because the Lua script is trying to jam it to a particular value. So I'm just going to shut that off for a minute so I can show you this. Stop the Lua engine. That's what I wanted to do. So you'll notice the cowl flap ratio is changing as I press this key. As it opens, see how it goes up, and it's going to go from 0 to 1 for each of these cowl flaps. Now, interestingly enough, these data refs you can actually manipulate. I can come in here and I can write to them. Notice that when I did that, this cowl flap went all the way down. Okay, so what I'm going to do in the Lua script is, based upon what state I put that shared data ref to, I'm going to do a calculation, and I'm going to set this to the value that I want. And just to show you how that shared data ref works, let's put in shared. Here's our shared data refs, and I'm going to actually poke at the cowl flap key here.
Cowl flaps open 25%. Cowl flaps open 50%.
Notice how that integer, that data ref shared int number 1, the very first one here, or 0, is incrementing.
Cowl flaps open 75%. Cowl flaps fully open. Cowl flaps open 75%.
So you see how that works? Now, nothing's going on down here because I shut the Lua engine off, okay? So now I'm going to come up here and say FlyWithLua, resume the Lua engine, reload the scripts, and
cowl flaps open 25%.
Notice how this is moving?
Cowl flaps open 50%.
Okay, let's look at the Lua script that's making that magic happen, okay? All right, so where do you find Lua scripts? Explain 11, resources, plugins, FlyWithLua, scripts. And if you follow the installation instructions, I told you to copy this be58.lua file from the samples over to here. So I'm going to simply open this up with Notepad++. We'll bring it over here and take a look at it. Okay. Now, to do Lua scripting, you are going to have to learn a little bit of programming. There are lots of examples. Not only are there tons of there's a lot of examples for X-KeyPad, but I will tell you that if you look at like X-SciTech panels, that's got the same situation. For the more sophisticated things, you often have to write a Lua script, to get it to do stuff. So, looking at the examples of the configurations for X-SciTech panels, the sample configurations for X-KeyPad, there's tons of examples of Lua scripts all over the place, okay? But basically, this is how Lua works. When a plane gets loaded, Lua will go through and execute all of the Lua scripts in the Lua scripts directory. So the first time through, as soon as a plane gets loaded, we have this if statement here. And what I'm saying is if the plain ICO code is a BE58, I want to execute this code. If you're loading a 737 or a Diamond 62 or a Cessna 172, I don't want to do anything, because clearly if it's not a Baron 58, none of this stuff makes any sense to be doing with another plane. Okay, if it just so happens to be you had a Lua script where it worked for multiple planes, you would actually have it do a if it's equal to this or this or this or the other ICO codes. And do keep in mind, sometimes, and you'll have to look at like the 737 example, sometimes you actually may have to have it look at the ICO code and maybe the tail number. A good example of this is you might have one script for the default Boeing 737 and a different script for the Zibo 737. The trouble with that is both of those planes have an ICO code of a B738. So you have to be able to distinguish which plane is loaded. And there are, like I said, a couple of datarefs you can look at, but make sure that the script is only running, okay, for the plane you've got. Otherwise, you can get some rather weird, behavior. So the first thing we come in here is if this really truly is the BE58, I'm going to define some names, okay, for some datarefs. So the first thing I'm going to say is I'm going to say shared 0 is this dataref here. It's writable, and index 0 is the one I want, because this is actually an array, dataref. The next what I want to do is the left cowl flap ratio. It's sim cockpit engine actuators cowl flap ratio. It's writable, and I want index 0 for the port engine. And then I do another one, right cowl flap ratio. Same thing, except it's array index number 1, which is the starboard cowl flap, okay? And what I'm going to want to do is initially set shared 0 to a 0, which means that the cowl flaps are fully closed, okay? Just so it starts up okay in a known condition. Then I'm going to define this function, evaluate cowl flaps, which we'll look at in just a minute. And then I basically define a callback. And FlyWithLua has a number of callbacks. Do often, what's going to happen is once you've defined do often, every second, then any function that you put in do often is going to get called once every second. You have, I think, another one called do every frame, which means that every frame in the simulator to get called. In our case, we don't need to do it that often. If there's up to a 1 second delay from the time I press the cowl flap switch to the time that it actually moves the cowl flaps, that's perfectly okay. You don't want to be running these things more often than they need to, although this script is extremely simple and FlyWithLua is blazingly fast. You could probably do this on every frame and it wouldn't hurt anything, but I didn't care if it, so what if it takes a second before these things respond? It was okay, to me. But every second it gets called, this function's now going to look at things, and all it does is a simple mathematical equation. It simply says take the shared zero value, which is going to be either 0, 1, 2, 3, or 4, and divide it by 4. Okay, so if it's set to 4, I divide it by 4. That's going to set the cowl flap ratio to 1, which is the cowl flaps fully open. Okay, or fully closed. I can't remember which way it goes, okay? But you get this sense. And then I simply set the right cowl flap to whatever I calculated for the left cowl flap, right? So this is an example of a Lua script where you can get single key presses to do relatively complicated things, and to do that, you will probably want to use a shared data ref to communicate to the Lua script, what state the key press is in, to give you kind of give you an example. Okay, so at this point I think I pretty much covered everything you could possibly do within these scripts and with the configurations. There's a pretty significant write-up in the documentation on how to do all this, but I think that walking you through in this rather lengthy tutorial and showing you where and how it gets used and what the logic behind it is, hopefully this helps a little bit in trying to get it done. Okay, thank you very much. And one parting comment I want to make in this is, if you're getting started with this and you bought an X-K80, my recommendation is to just, even though it's a little bit of a pain in the neck, just set your X-KeyPad up exactly the way I've got the samples. Print out the legends, load up the legends, and just work with these samples yourself until you get a feel for it. And then once you know how it's all working, then you can go through and you could do your own definitions, make changes, rearrange the keys, go crazy. But I will tell you, trying to do it from scratch, you might find it a little bit challenging. Okay, so I'll leave it up to you to how to do it, but that's my recommendation is try to use the samples I did for the X-KeyPad or the X-K60. I only did one sample for the Baron 58 there, but just start with that, get familiar with it, and then you can start expanding and making changes with it and get a sense of how it all works. Okay? Well, thank you very much for watching this, bearing with me for this very long tutorial, and I hope this really helps you to get going with X-KeyPad.